Okay, in this module, we're going to talk about network fundamentals and network security. I want to talk a little bit about fundamentals because not everyone in the class may have that background. If you do, this might be a little of a review for you. So let's talk about LAN switches and routers, local and remote packet delivery, DNS, domain name servers, and we'll talk a little bit about the two different formats for IP addressing, the IP version 4 and IP version 6. So every URL, you type in Amazon.com or Google.com. Behind that is an IP address, a number. And there's two versions, version 4 and version 6. And which 6 has some advantages as we move to that. So let's first go through how a network works. At a very high level, see here you have switch A and switch B here. These PCs or workstations communicate to the switch by using a MAC address. An MAC address is a unchangeable number, sort of burnt into the hardware that you cannot change, and the switch knows how to communicate among within this local area network by that MAC address. Okay, if you want to go to a different set of workstations on a different switch, like switch B, you have to go through a router. To go through a router, you need more than a MAC address. You need an IP address. So there's something, you don't need to know this, but there's a table called an ARP table, ARP, and it keeps track of the MAC addresses and the assigned IP addresses. So if this PC4 here on switch A wants to talk to PC5 here on switch B, they need to go past the switch, get an IP address from the router, and communicate through the router with an IP address to reach this other PC5 here on switch 2. And that's also how you communicate outside your local area network to the internet. So you need an IP address to talk to the internet. Okay, so those are the distinctions. MAC addresses are for within the local area network. A router needs an IP address if you're going to go from one network to another network, from switch A to switch B, different networks, or if you're going out to the internet, which is really sort of another network. So now you never key in. You key in a word like domain.com, whether it's apple.com or ibm.com, google.com, but there's an IP number behind that. What's keeping track of those, when you type in amazon.com or walmart.com, it looks up this number in this DNS server. That's what a DNS server does. It stands for domain name server. It's not really just one server. There's really sort of a hierarchy of them geographically and by the type of domain, whether you're going to a .com or .edu or .org. They're sort of segregated out by type of domain and location. But that's all it does. It translates your the name of the URL that you type in, like I say, apple.com, and it converts it to the number. And there are two versions of this. There's a version 4 and a version 6. So let's talk about that for a second. New IP internet addressing. Version 6, you don't need to know a lot about it. It gives you many, many more numbers, but it's more efficient and it's more secure. And it allows for what's called multicasting, simultaneous destinations at once. When there's a broadcast going out to many different locations or hosts, it's more efficient. So it's more efficient, it's more secure, and many more numbers. Those are the three differences between IP version 6 and the current IP version 4. So now we talked a little bit about how a network works, how the internet works at a very sort of high level. There's lots to do with protocols, which we don't have time to cover in this class. But let's talk about network security: firewalls, demilitarized zone, virtual private network, and managing remote access. So what's a firewall, right? So a firewall protects the internal company property, servers, data, and users from what's out in the internet, which is like the wild west, right? It protects from inbound exposure to viruses and malware and other maleficent activities, and inbound data, malicious inbound data. I should say, when I say outbound, I'm sorry, outbound exposure. I'm saying that backwards. You don't want your data exposed outbound. You don't want your data to be outbound, your corporate data. And you also don't want malicious inbound data like viruses and any sort of malware. So it's protecting data from escaping outbound, and it's protecting viruses from coming in and hacking coming in, or someone just wants to snoop around your network. And it's complicated in terms of the way it works. There's a lot of different settings you can use, but it basically can sanitize protocol flow. There are lots of different kinds of protocols, which are basically standards for the way you communicate over the internet. There's a whole stack and a whole set of these different protocols, and it filters and examines them, and it does a lot with protocols as well. So this is sort of a demilitarized zone. This is how it looks. So here's the internet, the Wild Wild West. You have an outside firewall here. You have an interior firewall. In the middle is what's called a demilitarized zone, which was used in the Korean War and the Vietnamese War to sort of, if there was at some point in time sort of a truce where there'll be no fighting in this zone. So that's kind of where this comes from, no fighting in this zone. So you'll have here your trusted servers in the demilitarized zone. You'll have email, e-commerce, things where you want people on the internet. You want the outside world to communicate to your e-commerce, to shop on your site, to exchange email with you. You put all of that in this demilitarized zone. And then behind this inner firewall is your corporate information, which you don't want to give access to the outside world. So the DMZ is this sort of middle area, this middle ground, protected by two firewalls. And for those of you who are more geeky, there are 3 network cards, one going to the internet, right, going outside, one going to the DMZ, to the various email servers or web servers in the DMZ, and the other going to the other firewall for the internal network. So that's kind of this isolation concept of this DMZ. It's really the basic concept of it, to put the items that you wish to have on the internet in this sort of semi-secured zone, and still protecting your corporate information and your private information here. I sort of got a kick out of this. A misconfiguration of the firewall, it can create havoc in terms of security consequences, but it could also create internal problems where sites you want to get to, you can't reach. Sites that you're supposed to reach you can't reach you. There can be performance bottlenecks. So here the manager is giving Dilbert the opportunity to install the new firewall, and he says, they get blamed for everything, which is really the truth in terms of what happens. But you can read this at your leisure. So the best way to communicate if you're home or remotely is through what's called a virtual private network. And essentially, a virtual private network, they put a little special software on your workstation or your PC in your home or your remote location, and it encrypts and tunnels with special protocols, sort of a private network, by using the internet. So you're not as exposed. You're sort of tunneling through with an encrypted, encapsulated communication. And then when you reach the company, so this is the internet connection utilizing these protocols on the public network with no security. But if you use a tunnel, then this will be encrypted and encapsulated. And then when you reach this VPN endpoint, it de-encrypts and gives you access to the corporate information. So you want to make sure you've got software on your machine if you're going to work remote for a virtual private network that your company supports. Managing remote access. So, there are advantages. Obviously, you should always use a VPN. Make sure it's secure. There's productivity. You can work from home. If there's a problem with the weather and you can't commute to work, again, people can work at home or remote locations. And it cuts down on overhead expenses, like the leasing costs in a building. So, I guess this COVID-19, this whole pandemic we're having is really sort of showing the value of remote access and the beauty of being able to work remotely. And I think more and more companies will be adopting that. But there are disadvantages. There are a variety of devices in people's homes. There are Apples. There are Windows machines, different versions of Windows. It can make support a little bit more complicated and difficult with different kinds of devices. You could have malware, or your personal device at home or remote location could be attacked. And again, you could, there's a potential you're going to infect the corporate world on the other side of this remote connection. And of course, you have to review the logs, who and where, what's happening, who's logging onto your system when, how often are they on. You have to make sure there isn't something odd going on, as I said earlier, with keeping track of logs so that you understand the secure. If you want to stay secure, you have to have some sort of concept of what's happening. I think I'm struggling for the word. benchmarks. You need some benchmarks in terms of how people connect and when, how often their logins fail, and to compare that to your activity to see if there are any outliers, if there's something unusual going on to help you identify problems. So that concludes our network fundamentals and network security module.